everyone! Welcome back to integralcalc.com. Today we're going to be talking about how to find velocity and acceleration vectors, and at the end we're also going to talk about how to find speed if you're given the velocity and acceleration vectors. So the problem that we're going to be working with is r of t equals ti plus t squared j plus t cubed k. And the first thing that we're going to do with this problem in order to find the velocity vector, which will be the first part of this problem, is to take the derivative of our original function r of t. So when we take the derivative, we're going to have r prime of t, and r prime of t, or the derivative, is going to be the same as the velocity vector, or it's going to be how we find the velocity vector. So when we're taking the derivative of our original function r of t, you can ignore pretty much I, j, and k. So it's almost easiest to just pretend that they're not there at all. If you visualize that I is gone and j is gone and k is gone, then you just take the derivative of this function as if it only included t's, like a normal function. So again, the derivative of t would just be 1. So we have 1 down here, and then we just put the I, we just add it back in. Pretend it's not there and then add it back in. So for this t squared j, pretend the j is not there, take the derivative of the t squared, and you're going to get 2t, and then just smack the j back on, and you get 2t times j. And then again, with this t cubed k, ignore the k, we've just got t cubed, we take the derivative and we get 3t squared, and then put the k back in, and we end up with 3t squared k. So that's the easiest way, I think, to take the derivative. And then to find the velocity vector with these direction numbers here, we're just going to go ahead and grab the coefficients on I, j, and k. So anything multiplied by I, j, and k, and in this case it's 1 on the I, 2t on the j, and 3t squared on k. And that's our velocity vector right there. So that's where we find velocity vector. Acceleration vector is going to be the second derivative of our original function r of t, or the derivative of r prime of t, which we just found. So you have r double prime of t is the same thing as a of t, or the acceleration vector. So again, we'll do the same thing, taking the derivative of this function so that we don't have to start all over. And we'll do the same thing we did before in terms of ignoring I, j, and k, and simply taking the derivative of t with respect to t, then adding those back in. So pretend the I is gone, which leaves us with 1 here. The derivative of 1 is 0. So that whole term goes away because the derivative is 0. This term here, 2t times j, again, ignore the j, and we're just left with 2t. To take the derivative of 2t, we simply get 2, and then we throw the j back in. So we end up with 2 times j. And then the derivative of 3t squared is 6t, so we get 6t, and then put the k back onto the 6t here. So that's our derivative. And then we'll do the same thing we did to find velocity vector, meaning that we'll take the coefficients off of I, j, and k to get the acceleration vector. So obviously we have no I left over, so the coefficient on that is 0. The coefficient on j is obviously 2, and then the coefficient on k is 6t. So that gives us our acceleration vector. And then to find the speed, what we'll do is take the, we use this formula here, we take the absolute value of the velocity vector, but what we're going to do is take the coefficients here in our velocity vector, 1, 2t, and 3t squared, and we're going to square each of them. So we square each of them here, and then we're going to take the square root, and that's just a formula. That's all. You always do the same thing. You take the 3 direction numbers in the velocity vector, square them, add them together, and then take the square root of the whole thing. So all we have to do to find speed then is just simplify this as much as possible. Obviously, 1 squared is just going to give us 1, 2t squared will give us 4t squared, and then 3t squared will give us 9t to the 4th. And we can just leave this as is. We don't have to simplify any further, we don't have to solve, but now you're given velocity, acceleration, and speed. So those 3 together give us our final answer. If you were asked now to find like velocity, acceleration, and speed at a certain value, like find velocity, acceleration, and speed when time equals 3, or 3 seconds after the start, or whatever, you would plug in 3 for t everywhere, and that would give you velocity, acceleration, and speed. So I hope that helped you guys, and I'll see you in the next example. Bye!